Guys, this is Chef Jin Academy. Welcome back to this channel. In today's video, I'm going to be showing you how to detail a reinforced concrete slab from the two-way slab, the one-way slab, and the cantilever slab. So I want to use this medium to thank everyone that have subscribed to our channel. We really appreciate you. You have been a motivation to us to keep creating content on this channel. So before we continue, if this is your first time or you've not subscribed, kindly hit the subscribe button and turn on the notification. Thank you. A two-way slab can be differentiated from a one-way slab using the aspect ratio. The aspect ratio signifies the ratio of the longer span to the shorter span. If the ratio of the longer span to the shorter span is less than 2, then we take the slab as a two-way slab. But when the ratio of the longer span to the shorter span is greater than 2, we take the slab as a one-way slab. In a two-way slab, the moment acting on the slab is critical in both directions, both the short span and also along the long span. So looking at this diagram, this is the moment representation of a two-way slab. But this can also be used to explain a one-way slab as well, even though the difference between them is clear. But in terms of detailing, there is no much difference between a one-way slab and a two-way slab in practice. So that means this diagram, we'll be using it to explain one-way slab and two-way slab detailing. Lx signifies the short span, Ly signifies the longer span. So definitely these are the moments acting along the slab. Mx and My are the moments at the mid span. So these are the moments at the mid span of the slab, while M1, M2, M3 and M4 are the moments at the continuous edges of the slab. In case if all our slabs are continuous, but if one of the end of the slab is not continuous, that means there won't be any moment at that end. So each of these moments must be resisted by reinforcement, because we know load is going to induce tension on the slab. So for us to counteract the load, we need to provide reinforcement that is very good in tension, so as to help concrete that is weak in tension. So the reinforcement that we'll be using to resist moment Mx is given as Rx, while that in which we will be using to resist moment My is given as Ry. The same thing goes for R1, R2, R3 and R4. So Mx is the moment along the short span, My is the moment along the longer span, looking at the direction of the moment. So definitely, when you are positioning moment Mx, when you are positioning reinforcement Ry and the Rx, they have to be along the span of the beam. So they are the reinforcement that will be placed at the bottom of the slab. In slab detailing, we have 4 layers of arranging reinforcement. So you can arrange reinforcement either using this first method, as you can see, where you have the bottom reinforcement, then you have the one above it, then you have the top reinforcement, then you also have the one below the top reinforcement. In a two-way slab, all these reinforcement provided are categorized as the main reinforcement. They are main reinforcement because we designed for them. They are important so as to resist moment. But in a one-way slab, the most important component of a one-way slab is the reinforcement that is provided along the shorter span, and which is Rx. In this case, is going to be Rx. So reinforcement Rx is going to be the reinforcement that will always be placed at the bottom position. reinforcement RX is the reinforcement that we place at the bottom position and is always going to be parallel to the shorter span of the slab. Reinforcement RY is going to be the reinforcement that's going to be above the bottom reinforcement. So it can also be called B2 or bottom top. So it's the reinforcement that will be provided immediately above the bottom reinforcement and is denoted by RX, RY, and is always parallel to the longer span of the slab, either one-way slab or two-way slab. So reinforcement R1, R2, R3, R4 are the reinforcements that we have at the continuous edges of the slab, and they are always positioned at the top portion of the slab, which is signified as T1. So they are always given as T1. We know typically a slab will have 4 edges. So R1 will be on one end, R2 will be on the other end. The same thing goes for R3 and R4. So the reinforcement that we are now going to put at position T2, which is the secondary reinforcement for reinforcement R1, R2, and R3 to R4, is the distribution reinforcement. Distribution reinforcement is a reinforcement that is not necessarily needed, that is not designed for, but it is needed in detailing. There is a link in the description of this video. In that link, I explain the difference between main reinforcement and distribution reinforcement. I also give a detailed explanation on the detailing of slab. Try to check it out. Moving on with the class. To detail the bottom reinforcement, which is in this case RX and RY, we said they are going to be positioned at the bottom of the slab. So RX is going to be parallel to the short span, as you can see in the diagram. RY is also going to be parallel to the longer span, as you can see in the diagram. So if you cut a section along the horizontal axis, you have something like this. So because if you cut a section, you'll be seeing RX, you'll be seeing the cross section of RX, and we'll be seeing the total length of RY. So this is how the reinforcement is going to be placed, is going to be positioned. To detail the top reinforcement, as we have explained earlier, the top reinforcement are the R1, R2, R3, and R4. When the slab is discontinuous, what do we mean by a discontinuous slab? A discontinuous slab means that the slab is not attached to another slab. So in that sense, you say the slab is discontinuous. So when a discontinuous slab is restrained means we have the slab is supported by a beam that is preventing it from torsional movement, from twisting, from rotating, that is preventing the movement of that slab, holding the slab firm. So in that kind of situation, we say the slab is fully restrained. So when the beam, for example, supporting the slab is preventing the slab from twisting and other movement. So when a slab is discontinuous and it is restrained, the top reinforcement, just like we have in this situation, is going to be returned into the slab by 0.15 multiplied by the length in which that reinforcement is parallel to. For example, R1, R2, these ends are discontinuous. So they are going to be returned into the slab by 0.15 multiplied by Ly. In case of R3 and R4, the end is discontinuous, there is no attached slab, so the reinforcement is going to be returned from the face of the beam. It's going to be returned from the face of the beam into the slab by 0.15 multiplied by the length, and in this case, this length is going to be Lx. So simple as that. So when the slab is discontinuous and it is restrained, then you return the reinforcement by 0.15 Ly 0.15 L depending on the length of the side of the slab in which the reinforcement is parallel to. So let's now move to another situation when the slab is continuous in one end. So you can see now that this end of the slab, this end, and this end, the three of them are not continuous because there is no slab attached to them. I'm talking about this end, I hope you get, and this end. There's no other slab attached to them. But if you look at this end of the slab, there's another slab attached to it. So let's say this is slab 1 and this is slab 2. So the reinforcement here, which is the top reinforcement here, if you look at the diagram, is going to be R3 for slab 1. And for slab 2 is going to be R1 using the orientation that I explained earlier. So R3 for slab 1 is going to be 0.3 multiplied by the length in which R3 is parallel to. The length in which R3 is parallel to is LY1. So that's going to be 0.3 multiplied by LY1. Then this reinforcement is also going to cut across the beam and also enters into slab 2. So and it's going to be returned into slab 2 by 0.3 multiplied by LY2. LY2 because this reinforcement is parallel to span LY2, length LY2. So this whole reinforcement is a single reinforcement, but that is how the curtailment is being done. So this is a simple way in which you can detail a two-way slab, either two-way slab or one-way slab. The major difference between both of them is that in a two-way slab, the main reinforcements are actually 6 in number. They are 6 in number, the maximum you can have if all the edges are continuous. They are 6 in number. But in a one-way slab, the only main reinforcement in a one-way slab is the RX, which is the reinforcement that is placed at the short span of the slab. The reinforcement that is placed parallel to the short span of the slab. So let's now take a look at the cantilever slab. For a cantilever slab, it can come in two ways as well. The cantilever slab can be continuous and the cantilever slab can be discontinuous. When the cantilever slab is continuous, it means there is another slab, either a one-way slab, it can be a one-way slab, it can be a two-way slab attached to that cantilever slab. So in that kind of situation, we say the cantilever slab is continuous. And that is what we can see in figure A. Yeah. Then figure B is the section of figure A along the horizontal line. While figure C is the other condition when this cantilever slab is discontinuous. To detail a cantilever slab, the main reinforcement in cantilever slab is the top reinforcement, which you also denote as the T1 reinforcement. And the reason for this is a cantilever slab moment diagram is always like this. This is how the moment diagram of a cantilever slab used to go. Don't mind my drawing. So this is the moment. So that moment is at the top. That is, the main reinforcement you need to provide for the cantilever slab is to provide that reinforcement at the top of the slab. So in detailing this reinforcement, we know that this reinforcement is going to span through the cantilever slab. So it's going to start after you've removed the cover for the slab, depending on the design condition or the exposure condition and other factors. So when you remove the cover, then from the cover, you extend the reinforcement throughout the cantilever end, as you can see in figure A. Then it crosses over the beam. Then this reinforcement is now extended into the adjacent slab when the cantilever slab is continuous. So it's extended into the adjacent slab by 1.5 multiplied by the length of the cantilever slab. I hope you get. Or 0.3 multiplied by Ly. So the reason why we have or 0.3 multiplied by Ly is because, you know, this panel, so let's say this is cantilever slab panel 1 and this is panel 2, which is a two-way slab. This two-way slab also have a continuous end. So in detailing it, it must also satisfy 0.3 multiplied by the parallel length. I hope we understand that. So that's why it is 1.5 multiplied by the length of the cantilever, or 0.3 multiplied by ly. So whichever of the two, whichever is greater between the two, is what you are going to pick. So let's say the length of our cantilever slab from the center line of the beam is 2 meters. This distance from here to here is 2 meters. And our LX is let's say 3 meters. So you multiply 1.5 multiplied by 2 meters, that will give you 3 meters, or 0.3 multiplied by 3 meters. Whatever that one gives you is going to be, I think that should give you something like 0.9. 0.9. So 3 meters is greater than 0.9. So that means this reinforcement is going to enter into panel 2 by 1.5 multiplied by LC, which is 3 meters. So the section of this slab in figure 1 is what we displayed in figure 2. So the top reinforcement is going to be extended into the adjacent slab by 1.5 LC, or by 0.3 LY. So let's now move to the second case, when the cantilever slab is discontinuous. So as we all know, when we say something is cantilevered, that is, the slab is overhang. That is, the slab has an overhanging end. So the overhanging end of the slab is what we call the cantilever slab. So when there is no other slab attached to that slab, just like we have in figure 1, there's no other, just like we have in figure C, there's no other slab attached to it. So in that kind of situation, the reinforcement, which is the top reinforcement, is going to be extended into the supporting beam, because this containment needs to be satisfied. And the reason why we are returning or extending that reinforcement is that we want to transfer the forces on the reinforcement into the support, because that is the condition of design, of analysis. What we analyzed was that this cantilever slab is being supported at the end. So this is what we are going to analyze for cantilever slab. So this is the support. So we need to extend that reinforcement into that support, since there is no other slab attached to it. So we extend the reinforcement into the support by 1.5 LC. So it can either take this form or this form. So these are the typical way in which you can detail a two-way slab, one-way slab, and cantilever slab. So let's now take a general example. If you compare the two diagrams by the left and by the right, the one by the left is trying to explain the detailing of the reinforcement, while the one by the right is explaining the moment position. If you look closely, based on the explanation that I gave, you quite understand that you have reinforcement for MX for the two. Let's say this is slab 1, this is slab 2. For the two slabs, which is this, you have reinforcement RY for the two slabs, which is this. Then you have reinforcement R1, R2, R3, R4 for the two slabs, which are the return reinforcement. So all these reinforcements follow the containment explained earlier in this video. In detailing, there is something we call calling out the reinforcement. We call it the call out. The call out shows the way in which the reinforcement is going to be arranged on site. It is not possible for us to start drawing all the reinforcement that you have. Let's say, for example, the total number of reinforcement, the total number of RX in this slab is 20. Then if we start drawing 20 bars, it will look cumbersome and it won't be readable by the site engineer or the end user. So in that kind of situation, we use the call out. So this is the call out for reinforcement RX. So it's showing that the reinforcement RX is spanning from here to here. Then also we start again from here to here. So the same thing goes for RY. This RY is going to start, this is the call out for RY. This is the call out. So it's going to start from here after you've removed cover to reinforcement, then end here. And it's going to run through both panel 1 and panel 2. And they are, so the bottom reinforcement are the ones in red color, while the green colors are the ones at the top reinforcement. So this, because this end is discontinuous, so we return it by 0.15. The same thing applies to this, return it by 0.15. The same thing applies to this, return it by 0.15. But in this case, this end is continuous, so we return it by 0.3. We return this one also by 0.3. Then you now ask me, what are the reinforcements in blue colors? Since I've explained to you the reinforcement in red colors and the one in green colors. So the one in blue colors are the distribution reinforcement. The position of the distribution reinforcement is the T2, which is also known as near top reinforcement. These are the reinforcements that we use to distribute the top reinforcement. So you can see that if you look at the span, you can see that MY and MX, they are both along the short span. So along the short span of the slab, you have reinforcement along the X, and you also have reinforcement along the Y. But if you look at this end, you only have reinforcement along the Y, which is this one, which is M1. Then at this end here, you only have reinforcement along the Y as well, which is M2. So you need another reinforcement that is going to counterbalance, that is going to distribute this reinforcement. So this reinforcement that is distributing this reinforcement is what we call the distribution reinforcement. And for M1, so this is the reinforcement. This blue reinforcement is going to distribute this reinforcement at the top. It's going to distribute this one. It's going to distribute this one, and it's also going to be distribute this one. If you look at the call out, this is the call out for the bar. You can see it spans from here to here. That is where this one starts to where it ends. Then where this one starts again, it's also continuing from here to here. Then where this one continue from here to here, because the reinforcement will not be placed on the beam, so it will not be put on in the beam position. So that's why we put this distance. Then it's also going to span this one from here to here. So that is the importance of the distribution reinforcement. So the distribution reinforcement is going to be the reinforcement that is going to be placed in order to balance the detailing. So the same thing applies to M3 and M4. There is reinforcement placed along the X, which is M3 and M4. So you need another reinforcement to be placed here. Another reinforcement to be placed here. So for panel 1, this is the reinforcement that was placed. This is the distribution reinforcement. So it's going to distribute this top bar and also this top bar. Then for panel 2, this is the reinforcement that was placed. So it's going to distribute these two top bar, because these two top bar are going to run through from panel 1 to panel 2. I hope with this video you've understand how to detail. I hope with this video you've understand how to detail and how to position your reinforcement correctly. If you find this video helpful, kindly hit the subscribe button and comment in the comment section. If you have any question, I'm going to attend to them. You can also share this video with your friends and make a lot of people to find this video on YouTube. Thank you. See you in the next one.